Hey math kids, today we're going to talk about solving exponential equations using logarithms. And so they want us to solve this equation exactly. And the way we get rid of a 2 is we're going to say log base 2 of both sides. And when we do that, 2 cancels log base 2, so it's just x. And then this is going to be log base 2 of 30. Okay, and then it wants us to take that answer and use the change of base formula so we can use a calculator. So I'm going to plug in natural log of 30 over natural log of 2 into a calculator. Okay, and that's 4.91. Now the next one, they want us to find exactly the answer to both of these. Okay, so the first one, if we have an exponential base of e, we have to use natural log of both sides. E cancels natural log, so we get natural log of 30. Over here, we need to divide by 3 first. Then, since everything that's left is inside of e, we use natural log to get rid of the e. Oops, that didn't right. Okay, and then multiply both sides by 2. And that answer is good. You could take the 2 up here and make 7 squared and also write it as natural log of 49 if you want to. Okay, it says find exactly the points of intersection for y equals e to the x minus 3 and y equals 1 minus 3e to the negative x. And then check our solution with technology. Okay. So I'm not going to check it with technology just because you could plug both these into Desmos and see where they cross, and I think you guys can all handle that. Now the way we do it algebraically is we set both these equal to each other. Okay. Now, because we have e to the x, e to the negative x, and constants, this is actually going to turn out to be like a quadratic pattern. So I'm going to move everything onto one side. So I'm going to subtract 1, add 3e to the negative x, subtract 1, add 3e to the negative x. So that gives me e to the x minus 3 minus 1 plus 3e to the negative x equals 0. Okay. These combine to make negative 4. And what I'm going to do, I'm going to multiply everything by e to the x. Now the reason I'm doing that is because I want this to be e to the 2x, and I'll kind of explain that why. Now e to the x and e to the negative x is going to be e to the 0, which is just a 1. This times 0 is still 0. Okay. Now if I think of this as e to the x squared, e to the x, oops, should be a plus sign there, then that's really just a 1, so it's 3. So now I can say u is equal to e to the x, and so we get u squared minus 4u plus 3, and we can use factoring methods now. U minus 1, u minus 3 equal to 0. Plug this back in for u, e to the x minus 1, e to the x minus 3. We can set both those equal to 0. add 1, e to the x equals 1, natural log both sides, those cancel, x is equal to natural log of 1. Now, natural log of 1 is just 0. So if we plug that into a calculator, let's just test that. Okay, natural log of 1 is just 0. So we get x equals 0 for that first piece. This one we're going to add 3, add 3. I just ran out of room. So we end up with e to the x equals 3, natural log both sides, those cancel, x is equal to the natural log of 3. Now we're not done because the question wanted us to find the points of intersection of these two things. So what we have right now, we have two x values, but we're missing our y values. So we can choose either equation, doesn't matter. But I'm going to plug in a 0 to this one. I get e to the 0 minus 3. E to the 0 is 1. Minus 3, that gives me a negative 2. If I plug in a natural log 3 here, I get e to the natural log of 3. E and natural log cancel, so it's 3 minus 3, which just gives me a 0. And so these are the 2 points that they intersect. Once again, you could plug both of these into Desmos, see where they crossed. You'll see they'll cross twice, once at 0, negative 2, and once at natural log 3 of 0. If you need to know a decimal for natural log of 3, plug it into a calculator and then make sure on the graph that that's the same spot. Okay, we have, I think, one more question. Yeah. So we have a farmer. I actually think we used this on a previous question, but there's an insect plague. And this is the number of acres that are affected. Okay, so it says use technology to help sketch the graph of AN, hence estimate the time taken for the affected area to reach 5,000 acres. Okay, so what we're going to do, we're going to go to Desmos. We're going to use the regular Desmos though. So graphing calculator, we're going to say y is equal to 1,000 times 2 raised to the 0.7n. Okay. Okay, so we have this graph. And what we're going to do, we're going to change our graph. So on Desmos, we can come over here, hit this wrench, and we don't really want our x to go that far. So let's just do like 0 to 4, or 0 to 5. Let's do that. Okay. And then on the bottom, we're going to go maybe 0. They want us to look at 5,000, so let's go to 6,000. Okay. Now, that's going to be a little bit easier to see what's going on. And they want us to see what happens when y equals 5,000. So just do that. See, and it says 3.317 weeks is where that's going to happen. So just like 3.3 is fine. And then we're going to check our answer using logarithms. So we're going to get rid of this. and we're going to plug in 5,000 for an, and then we're going to solve for n to see what we get. So remember, our answer was about 3.3 using the graph. Okay, we go through the algebra. We divide both sides by 1,000. So that's going to give us 5 is equal to 2 raised to the 0.7n. Okay, the way we get rid of a exponential with base 2 is log base 2. So these cancel, and we get 0.7n, and we get log base 2 of 5. Now we're going to divide by 0.7, 0.7. So we have log base 2 of 5 divided by 0.7 is equal to n. And so we want to figure out what this is. So to find the value of the top, we're going to do natural log of 5 over natural log of 2. Then we're going to take that answer and divide by 0.7. Now what we're hoping is that that is somewhere close to 3.3. So let's just type it in here. I already forgot what we had. Okay, so natural log 5 divided by natural log 2. And then if we take that entire answer and we divide that by 0.7, we get 3.317, just like we got when we looked at where they crossed. So see, the x value is the same as what we got doing it algebraically. If you have additional questions, please come to Math Lab. Until then, calculate.